Welcome back to Cloud 42. I'm James. Well, as you no doubt know, unless you've been living under a rock, and at that a rock without internet access, you know that the world is facing a viral pandemic. And we have a lot of brave men and women in our medical community who are working very hard day in and day out to defeat this virus and to protect all of us. But just their training and their willingness to work hard to fight this virus are not enough. They need personal protective equipment to keep them safe and to protect them from getting infected and getting sick so that they can work in close proximity to patients who need their help. And right now, that personal protective equipment is very hard to get. Normally, the global supply chains do an excellent job of moving product around to meet needs. If you have an area that's got some kind of a situation where you need a lot of personal protective equipment, you can move it from other areas that are less affected in order to meet that need. But because this is affecting everywhere on the globe at the same time, that just isn't possible. This stuff is in short supply. In the area where I live here in Idaho, the local hospitals in particular are having a very difficult time. In addition to the masks, they have a difficult time getting face shields. And the face shields are very important in situations like when you have a patient who needs to be put on a ventilator and you need to intubate them and actually insert a breathing tube. During that process, all kinds of fluids can get aerosolized into the air and directly into the faces of the doctors and nurses that are working with those patients. And so a clear protective face shield is really essential in that situation. And right now, they just aren't available. And this is where this part comes in. This is a 3D printed face shield headband. This is part printed in ABS, and the back of this is flexible so that it stretches to fit over any size head. There's some other features in here like an anchor hole, I believe, for a rubber band that comes around to this peg for tensioning it if needed. And then there are pegs on the front to hold a clear plastic sheet as the front of the face shield. And I don't have any of those there. I'm just 3D printing these plastic parts. Now you'll note this design is a little bit different than the ones that you may have seen on the internet that Joseph Prusa published. At least the first iteration of that had this area open. So you have an inner band that goes against the forehead and an outer band to hold the shield, and this was open. My understanding is that the hospitals here looked at that design and rejected it and wanted this closed off. So this is an iteration. In fact, this is version 8 that the maker community here in Boise has been working through with the local hospitals, and in fact, these are now being made in volume. Now, if you want to help and you would like to do something like this in your community, I highly recommend you go check out a video uploaded a few days ago by Destin at Smarter Every Day, where he really talks through what is required for the maker community to come into a situation like this and actually be helpful. As much as we'd all love it, you can't just download a file, print a part like this, and take it to your local hospital and expect that to actually help them. It really requires more organization than that. It requires a bigger organization to work with the hospitals, find out what they need, produce the products that they need, sanitize them, package them, produce documentation, raise the money to run the operation, get things delivered where and when they're needed, and it really takes more than just one person. Fortunately, we have a lot of active maker communities in this country, and in fact all over the world, that are up to that challenge. There's a group here in Boise, run out of Boise State University and a makerspace there, and several local businesses, and the local library district is involved, and there are some companies that have jumped in that have organized the effort here in Boise. So in order for me to help, all I have to do is hook up with that group, get connected with their Slack channels, the website, their email list. They send out the files, they tell the community how many they need, and we start 3D printing. So this particular headband, I can produce one of these in about 2 hours. I've got 2 printers, so I can produce about 20 of these a day depending on how much sleep I want to get. And I can package those up. There's an unattended drop point, no contact drop point where we can take them, drop them, somebody else picks them up, does the sanitizing, the packaging, somebody else is laser cutting the clear plastic sheets, and then ultimately delivering these to the hospital. And in this particular case, the hospital here in Boise is then handling distribution to other medical facilities throughout the state. So I am not directly involved in that part of the process. I just get to see the part where I print these and I go drop them off. And it is my understanding, though, that the maker community here delivered, I think, 675 face shields just this week. And we've got orders for hundreds more, and so we are printing as fast as we can. Let me grab a camera and take you upstairs, and I'll show you what we've got going on. This is my workroom. This is just a spare bedroom in the house that I have converted to my indoor shop. Now, this may come as a little bit of a shock to you, but not everything that in my house and not every place that I work is as neat as what you see on video. I actually work pretty hard to keep a very clean image in the videos. Got lots of light. I tend to use a lot of white backgrounds and a lot of clean surfaces and clean the chip trays on the machines before I start. Just trying to create a very kind of pleasing, clean aesthetic. This is not that. This is where the actual work gets done. By the time you see something that appears on video, or by the time I start filming something in the shop, especially electronics projects, it's probably come through here first. This is where I do my experimenting. This is my soldering bench. You can also see I've got a bunch of RC aircraft up here. There's a camera drone that I built, a couple of RC airplanes on the walls, and then a lot of RC airplane parts on the pegboard here. But this is my soldering workbench. This is my binocular microscope that I use for soldering. This is pretty nice, and especially when your eyes get to the state mine are at my age, having something like this to work under is just amazing. There's my little Heiko soldering station, and underneath that is the hot air rework station that I use for surface mount stuff. And just, tools on the bench, and you'll probably have fun pausing this and picking through all of the stuff that's here. Some parts that I've reclaimed from old power supply PC boards various times. There's some parts here that I've been experimenting with for tool holders to go in drawers for the tool holders for the new CNC mill spindle. And here's some of the tools that I had up here for the prototyping. There's spools of 3D filament everywhere. There's a motor laying there. Anyway, this is my 8-inch 3D printer. This is a Maker Farm Prusa i3V. This particular printer is about, it's probably 6 years old. I think I built it in 2014. At the time, it was using round rods, and so then I got an upgrade kit to switch it over to the linear rail with the Delrin rollers on it. This printer has, the original parts that came from Maker Farm, and so the frame is laser cut wood. I think it's MDO plywood or MDO, and it was laser cut. And when it came, it was just bare wood, and it smelled like smoke because it had come off of a laser cutter. So I decided to lacquer everything just to try to reduce that smell. And as long as you're going to be applying lacquer to something, it might as well be black, because black. So that's what I did. So the thing's black, and I think it gives it a really nice aesthetic look, and I've really enjoyed it, especially with the blue display up there on top. Now, that is not the stock extruder. The stock extruder that came on it was gear driven with a NEMA 17 motor. This is my own design. This is the itty bitty belted extruder that I've got kits available for the belts and stuff, but it uses a GT2 belt drive and a NEMA 14 motor, which makes it quite a bit lighter and nearly as strong. I haven't had any issues with it. It's got my own hob bolts in there that I CNC with the teeth on them, and this one extruder has been running for years. I put it on the printer and haven't really messed with it. All the wiring harnesses go up to a little connector block that I built up here. The parts for these connector blocks are out on Thingiverse if you're interested. But the first connector is just for all of the stuff like the cooling fan and the servo and the limit switch for setting for the auto leveling. And then there's 2 connectors here for extruders. So I've only got a single extruder on here. So there's 1 heater circuit and 1 thermistor and 1 stepper motor on that. And if I had a dual extruder on the printer, I would use this other connector. But right now that one's just outfitted with a single. And this is an 8-inch bed, which kudos to whoever designed this headband for these face shields, because getting that thing to fold up and fit on an 8-inch bed was just a masterpiece of design work, especially the way the part is flexible and the way it opens up and fits on the head so well. I gotta hand it to whoever designed this, and I don't actually know who that was. But making it work on an 8-inch printer, of course, opens it up so a lot more people can participate in the project, because these 8-inch printers are so common. When this project first started, all the documentation said you needed a 9-inch printer, but those are pretty rare, so I'm glad they got this worked out so that people with 8-inch printers can participate. And then that's a camera mast with a camera cable that's going back down to the Raspberry Pi back there running Octopi, which is how this printer is controlled. And of course you can see the HP printer, or the HP server power supply laying on the bench back there. The powers everything. And then the Arduino based controller, that's a Ramps. In this particular case, I think it's a Torino board underneath there. And then past the stack of old HP test gear that I'm either using, or in this case this pulse generator is waiting for some work to make it healthy and operating again. Got a computer here that I use for running the 3D printers and also for shipping products when I sell things. This is the label printer that spits out the 4x6-inch labels for shipping. And then this is my 12-inch printer, also printing a headband right now. This is also a Prusa i3V kit from Maker Farm, and it's the same laser cut MDO wood, lacquered black, and I've got the same connection system up here, though in this case I've actually got 3 cables connected because this is my dual extruder design. And again, it's all 3D printed parts. The stuff's all out on Thingiverse if you're interested. For a long time I sold kits for these, but I think I just sold the last one last week. And it's just the hardware kit. You can actually build this yourself in 3D print and buy all the parts you need. But I had kits with all the screws and the fiberglass insulators and everything that was needed to put this together. But this is just running a couple of E3D V6 hot ends and a pair of NEMA 14 motors. And it looks big and it looks heavy, but as far as direct drive extruders go, which this is, it's about the same weight as a single extruder running with a NEMA 17 motor. So this whole assembly weighs just slightly less than the single extruder that came on this printer. And very little on this printer has stayed the way it came from the factory. I ended up making new Z end stop mounts so that I could get more X travel, so that I could reach the entire bed with both nozzles, and in fact I could get the nozzles off the side for purging and wiping. I've got my camera mast design here, and again those parts are all out on Thingiverse if you're interested in that. And then you can see the bed there is not the standard PC board bed. I had a lot of trouble with getting even heat with that, so I got a 300 millimeter silicone industrial heater pad. So it's sitting over the top of some insulation underneath the glass. And that was quite an experience putting that in. The amount of power that that puts out compared to a standard PC board heater that you'd normally have on one of these printers is impressive. I was powering it up, it would heat for about 45 seconds and then the sheet of glass would explode. And I ultimately determined that I had set up the thermistor incorrectly, so in 45 seconds it was going from room temperature to 140 Celsius and exploding the glass. And I did 2 things. I switched to borosilicate glass because the heat up is so fast on this, but then I also got it under control, so it's only going to 100 or 110, but it does that in less than a minute, so that's a huge time saver if I'm printing a lot of parts or running a lot of things like I am right now. And then this is kind of my shipping area. You can see my box of packaged ELS PC boards. I've got more that haven't been packaged yet. There's a scale back there. You can kind of see the leftovers from the carbide inserts that I've also got listed. Quite a few people have picked those up, which is a big help for the channel. And there's lots of miscellaneous stuff that I'm sure I'll hear about in the comments. These are some taper shank scraper handles. This is an extra contactor like the one that I used in the VFD control box for the new mill spindle. And this is something you haven't seen yet. This was a test print for a nose piece for my drill press, so I can put a tachometer and controls for a VFD. These are some of the test prints for ramping up production of the 3D printed bridges that go in the ELS control panels, though that project is now on the back burner because my 3D printers are occupied for the time being printing PPE equipment for our local hospitals. So that's higher priority. That's what these printers are going to be doing for the foreseeable future. Once we're through this global pandemic, then I will pivot back to other kinds of projects that for now are just less important. This is kind of fun. Every shop ought to have some artwork. And then over here is my I've got a storage unit with all of the products that I ship all organized into bins. So this is the shipping department, and packing materials on the floor, and there's a lot of stuff on the floor in here. This is kind of a running theme, but this is a space that actually gets used. This is a working space, so it does not ever get cleaner than this. Every once in a while I get so frustrated I take some time and clear off the bench, and it doesn't stay that way very long because that just makes room to pick up some more projects. So these prints on these printers, I am printing on glass with hairspray, and yes, that is old school, but you know what? It works, and it works remarkably well. The hairspray that I use, I've been using for years, is this Garnier Fructis Extreme Control number 5. This stuff is amazing, and it's got, you know, several different polymer agents in it. I think it's actually got vinyl, liquid vinyl as a part of it, and it just holds, but you put hot water on it and it comes right off. So, and on the printer bed, on the glass, ABS in particular just sticks to it really well, and it holds well. I don't generally have any problem with delaminating off of the bed, especially on the large bed with the nice even heater under it. But then as the part cools, the natural shrinkage in the plastic makes it just pop off. So if I give it 20 minutes to come down to room temperature after a print, I'll come in here and the part will just be sitting on the glass. But there does tend to be a little bit of residue from the hairspray on the plastic, and so on these particular parts, I do clean that off. In some cases it doesn't matter, but I don't know how these are going to be sterilized, and so I don't want to contaminate the sterilization baths. So the next stop is the bathroom, where I scrub that off. Never thought I'd be filming in a bathroom for a YouTube video, but here we are. So when the parts come off the printer, especially this large flat surface on the top of the brim, there tends to be hairspray residue. So I run that under hot water in the sink and scrub with a brush, and that just comes off nice and neat and leaves a nice clean surface. Dry that, and then once it's dried and all the water that I can see is shaken off, I end up just laying them out here to air dry to make sure that there's no trapped water in them when they go in the bags for delivery. And then once those go in the bags, they end up in a bin over here that I have sitting on this handy porcelain shelf. And these are bagged up 4 to a bag, and these will be delivered to the makerspace down on the Boise State campus. And from there they go, I know not where. There are people that are doing sterilization of these things and are doing packaging and delivery to the hospitals. I saw a post earlier today that I think we delivered 675 of them to St. Luke's. There's an order for 200 more for somebody else, and orders keep coming in. So until the supply chain is restored and the commercial parts are readily available, we will keep making them because we can, and it's something that we can do to help. You can see the camera gear. This is just a little GoPro on a stabilizer mount using my cell phone as a viewfinder. And like I said, I didn't know that I would ever film in a bathroom, but here we are. As long as we're up here, I can show you a couple of more things. As you know, we're all in quarantine. We're all at home. Idaho has a stay-at-home order that's been in place now for a couple weeks and will continue for the foreseeable future. So the gyms are all closed. And if you followed my channel for a while, you know that a couple of years ago, I made a big change, lost a whole bunch of weight, and kind of became a gym rat, and been gotten into strength training and powerlifting in particular. So losing the gym has been a big deal for me and for my wife. And so we went ahead, and just before all of the gear disappeared, we managed to snap up enough to get a squat rack here at the house. This is just a little lightweight one, rated I think for 300 pounds, and we got a standard barbell. I know it's not an Olympic bar, but it's what we could get in the time frame that we had before everything was gone, and we managed to get about 330 pounds worth of plates and get set up in here. So 330 is enough for me to squat. It's enough for me to press and bench. And I can deadlift 330 for reps. I would prefer to have more available, but I don't have that right now, so I will take what I can get. And we did manage to pick up an incline bench and some other gear. This whole thing started out, I was thinking, oh yeah, we'll just grab a couple of dumbbell handles and we'll get some plates and we'll just be able to do some body weight and some dumbbell stuff here at the house. And then it kind of turned into this, and we've really been enjoying it. In fact, once this whole thing is over, we'll consider actually getting some good equipment and setting up a proper home gym, just because we've enjoyed working out at home so much. And as long as we're up here, I might as well show you this one more room. We had 3 kids, so this is the 3rd room that we've repurposed when they all left home. And this is my wife's sewing area. She's into quilting, and so we've got this set up for her with lots of really great light. These are the same lights that I use in the shop. And she's not the only one that uses this space. I've done some sewing in here of sandbags for my video gear, and just last weekend I was in here and sewed some face masks, because now that's the new recommendation for when you go out in public, go grocery shopping. So sewed a couple of face masks out of one of my favorite fabrics, black Kona cotton. Black because black. It's actually kind of cool, because when I learned to sew as a kid, we had a mechanical sewing machine and they had to be serviced all the time because there's gears and cams and timing that has to be set. And that is not how things are anymore. This sewing machine that we picked up for my wife when she started quilting is basically a CNC machine. There's no gears or cams, there's motors and servos, and the whole thing is software controlled. And so it's just a little CNC machine, but instead of removing material from a block with a rotating cutter, it's using a needle to force thread through and knot it through fabric. So it's just fascinating to me to see how that technology has progressed. And yeah, I love seeing stuff like this. And yes, I do sew, and yes, I do cook, and yes, I am a musician, but I don't have time for all of that, so I do the stuff that I enjoy. And you get to see some of that on the channel. Well, that's all I have for today. I didn't know this was going to turn into a behind-the-scenes tour, but there you have it. I know there's been some interest in that, so you've gotten to see a little bit of this. Maybe we'll do more if you enjoy this. Maybe we'll do a tour of the shop at some point. It's in slightly better shape than this, but not terribly. So if you're enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.